The year 2016 marked the arrival of a machine that would redefine the limits of automotive performance. The Bugatti Chiron, an unprecedented hypercar, emerged from the Volkswagen Group's engineering division as a testament to what was possible. It wasn't merely a successor to the legendary Veyron, it was a quantum leap, designed from the ground up to achieve staggering new benchmarks in speed, power, and aerodynamic efficiency. With its formidable 1,500 horsepower, the Chiron wasn't just fast, it was engineered to conquer physics, setting a new standard for the fastest production car of its generation. Bugatti's name has long been synonymous with automotive artistry and unparalleled performance. From the Type 35 to the EB110, the marque consistently pushed boundaries. When Volkswagen Group acquired Bugatti, the challenge was clear: to continue this legacy, not just with luxury, but with revolutionary engineering. The Veyron had already shattered the 400 km/h barrier, but the vision for the Chiron was bolder: to exceed that, to build a car that not only looked like a sculpture but could outrun virtually anything on four wheels, all while remaining street legal. At the heart of the Chiron's monumental performance lies its unique powertrain, an 8.0-liter quad-turbocharged W16 engine. This wasn't merely an upgrade from the Veyron, it was a re-engineered masterpiece. The W16 configuration, essentially two narrow-angle V8s joined at the crankshaft, allowed for a compact yet incredibly potent engine block. Volkswagen's engineers faced the daunting task of extracting unprecedented levels of power from this colossal engine, ensuring reliability and efficiency alongside raw, brutal force within a production car framework. The engineering directive for the Chiron was audacious: 1,500 horsepower. This figure was not just a target, it was a declaration of intent, an astronomical output that demanded every component be designed and manufactured to the absolute limit. To put this into perspective, it's more than double the power of a typical Formula One car of the same era. Achieving this meant rethinking fundamental aspects of engine design, material science, and thermal management, all converging to create an engine that was truly in a league of its own, capable of propelling the Chiron into automotive history. To unleash such immense power, the W16 engine utilized a sophisticated quad-turbocharging system. Unlike conventional setups, the Chiron employs two-stage turbocharging. For turbos work in pairs, two smaller turbos provide instant boost at lower RPMs, virtually eliminating turbo lag. As engine speeds climb, the two larger turbos engage, delivering the full, relentless surge of 1,500 horsepower. This intricate ballet of forced induction ensures a smooth, linear power delivery across the entire rev range, making the Chiron's acceleration both brutal and remarkably controllable. The W16 engine's unique configuration is key to its packaging. While a traditional V16 would be excessively long, the W arrangement, essentially two narrow-angle V8 cylinder banks sharing a single crankshaft, is remarkably compact. This design decision was crucial for fitting the massive 8.0-liter engine, its four turbochargers, and the extensive cooling system within the Chiron's sleek bodywork without compromising cabin space or aerodynamic efficiency. It's an elegant solution to an enormous engineering challenge, demonstrating Volkswagen's commitment to innovation. Generating 1,500 horsepower creates an astronomical amount of heat. Managing this thermal output was one of the Chiron's most formidable engineering challenges. The car is equipped with no less than 10 radiators, circulating over 49 liters of coolant to keep the engine, turbos, and intercoolers within optimal operating temperatures. This colossal cooling system is a testament to the extreme conditions the Chiron is designed to endure, ensuring performance remains consistent whether cruising or undergoing a top-speed run. Without such a robust system, the engine would quickly self-destruct. While raw power is essential, achieving record-breaking speeds and maintaining stability at over 400 km/h demands equally sophisticated aerodynamics. The Chiron's sleek silhouette is not just for aesthetics, every curve, vent, and line is meticulously sculpted to manage airflow. Bugatti's engineers focused on two critical aspects: generating sufficient downforce to keep the car glued to the road and minimizing drag to allow it to cut through the air with minimal resistance. This balance is pivotal, dictating both its top speed potential and its handling dynamics. Key to the Chiron's aerodynamic prowess is its array of active elements. The most prominent is the adaptive rear wing, which can deploy in various positions depending on speed and driving mode. In handling mode, it angles up to create maximum downforce for cornering stability. In top speed mode, it flattens to reduce drag. It also functions as an air brake, deploying at a steep angle to assist in rapid deceleration, generating significant braking force. This dynamic system ensures optimal aerodynamic performance in every scenario, a true testament to its versatility. To achieve its ultimate top speed, the Chiron transforms into a streamlined missile in top speed mode. The suspension lowers significantly, reducing the car's frontal area and the amount of air flowing underneath it. The active rear wing almost entirely retracts, minimizing drag to an absolute minimum. This meticulous configuration is manually engaged with a special speed key, underscoring the extreme nature of the mode. Every millimeter of the car's posture is optimized to reduce resistance, allowing the Chiron to punch through the air at velocities that defy comprehension. The Chiron's aerodynamic efficiency extends beyond its active wing. Massive frontal air intakes are strategically placed, not just for the W16 engine but also to feed the vast cooling systems. Air is carefully channeled around the cabin and through the engine bay, then expertly evacuated through rear vents and the prominent rear diffuser. This underbody management creates a Venturi effect, further increasing downforce. Every aperture, every duct serves a purpose, preventing turbulence and optimizing the flow of air, crucial for both cooling and stability at extreme speeds. At the speeds the Chiron achieves, structural rigidity and safety are paramount. The Chiron utilizes a full carbon fiber monocoque chassis, making it incredibly stiff yet lightweight. This advanced composite structure provides exceptional torsional rigidity, comparable to that of an LMP1 race car, ensuring precise handling and driver feedback. It also forms a robust safety cell, protecting occupants in the event of an impact. This commitment to cutting-edge materials science underscores the relentless pursuit of performance married with uncompromising safety standards. The interface between the car and the road, the tires, becomes critically important when dealing with 1,500 horsepower and speeds exceeding 400 km per hour. Bugatti collaborated closely with Michelin to develop bespoke tires specifically for the Chiron. These tires are not only designed to withstand the enormous forces and temperatures generated at extreme velocities but also to provide the necessary grip for both acceleration and braking. Each tire is meticulously inspected and balanced, a bespoke masterpiece of rubber and compound technology, crucial for safety and performance. Before a single physical prototype will turn, Volkswagen engineers extensively utilized advanced virtual testing in computational fluid dynamics, or CFD. Millions of hours were spent simulating every aspect of the Chiron's performance, from engine thermodynamics to aerodynamic airflow and chassis stress. This digital prototyping allowed engineers to refine designs, identify potential issues, and optimize performance parameters with incredible precision, significantly accelerating the development process and reducing the need for costly and time-consuming physical iterations. It was a fusion of digital prowess and mechanical ambition. Even with extensive virtual testing, real-world validation at extreme limits is indispensable. The Chiron was subjected to grueling tests at the Nardo Ring in Italy, renowned for its high-speed banking, to hone its handling characteristics. However, for top speed runs, the Aeroleschen test track in Germany, Volkswagen's private facility with an 8.7 km straight, was the ultimate proving ground. These high-security facilities allowed engineers to push the Chiron beyond anything achievable on public roads, meticulously gathering data and confirming its world-beating capabilities under controlled conditions. The culmination of years of relentless engineering came on August 2, 2019. On the hallowed asphalt of Aeroleschen, a modified Bugatti Chiron Super Sport 300 Plus embarked on a mission to break the seemingly mythical 300 mph barrier. This special variant, elongated for aerodynamic efficiency and slightly more powerful, was the ultimate expression of the Chiron's potential. With former Le Mans winner Andy Wallace behind the wheel, the car not only crossed the 300 mph threshold but surpassed it, writing a new chapter in automotive history and stunning the world. Achieving such a monumental speed record wasn't solely about the machine, the human element and environmental conditions were equally critical. Legendary test driver Andy Wallace, with his vast experience in high-speed runs, piloted the Chiron with unparalleled skill and precision. Perfect weather conditions, low wind, optimal air temperature, and a dry track were essential to minimize external variables. Every factor, from tire pressure to fuel load, was meticulously managed, ensuring that on that historic day, the car, the driver, and the environment aligned perfectly for a flawless record attempt. While the Chiron's top speed record captures headlines, its overall performance envelope is equally staggering. The car accelerates from 0 to 100 km per hour in just 2.4 seconds, an astonishing feat for a vehicle of its weight and luxury. Equally impressive are its braking capabilities, capable of decelerating from 400 km per hour to a complete stop in a mere 9.3 seconds. This holistic approach to performance, not just ultimate velocity but also brutal acceleration and incredible stopping power, highlights the Chiron's comprehensive engineering excellence, making it a true all-around hypercar. The Bugatti Chiron is more than just a fast car, it's a rolling laboratory of extreme engineering. Its development pushed the boundaries of material science, thermodynamics, aerodynamics, and powertrain technology, serving as a crucial testbed for innovations that will undoubtedly influence future automotive designs. Lessons learned from managing 1,500 horsepower, controlling airflow at supersonic speeds, and ensuring driver safety under such immense stress have provided invaluable insights for the broader Volkswagen Group, impacting everything from active aero systems to lightweight chassis construction across their performance divisions. The Bugatti Chiron secures its place in history as the fastest production car of its generation, a shining testament to Volkswagen's unwavering commitment to engineering excellence. It stands as a pinnacle of internal combustion engine performance, showcasing what is possible when ambition meets unparalleled technical prowess. Its iconic W16 engine, groundbreaking active aerodynamics, and meticulous performance testing collectively forged a legend. The Chiron embodies Bugatti's spirit of form follows performance, leaving an indelible mark on the automotive landscape and inspiring generations to come. Beyond the headlines of horsepower and speed, the Chiron's brilliance lies in the thousands of unseen details. From the specific alloys used in its engine components to the precision-engineered fasteners, every single part was subjected to rigorous analysis and refinement. Hundreds of engineers, designers, and artisans poured countless hours into perfecting every aspect, understanding that true performance at this level is the sum of infinite meticulous efforts. This microscopic attention to detail ensures not only record-breaking capabilities but also the reliability and luxury expected of a Bugatti. The Chiron's extraordinary achievements set a formidable benchmark for the hypercar world. It demonstrates that with sufficient engineering ingenuity and resources, the limits of what a road-legal car can accomplish are constantly being redefined. As the automotive industry shifts towards electrification, the Chiron stands as a monumental capstone for a generation of internal combustion power, paving the way for future innovations. Its legacy is not just about raw numbers, but about the relentless pursuit of perfection that will continue to drive automotive development for decades. The Bugatti Chiron is a magnificent triumph of engineering, a machine that transcended mere transportation to become a symbol of human ingenuity. It represents the pinnacle of what Volkswagen's engineering division could achieve by combining audacious vision with relentless pursuit of technical mastery. From its monstrous quad-turbo W16 engine and revolutionary active aerodynamics to the exhaustive testing regimes, every facet of the Chiron was designed to shatter expectations. It is, unequivocally, the fastest production car of its generation, and a timeless masterpiece that will be admired for centuries.